It's my view that climate change is real, serious, and deserving of serious attention to both mitigation and adaptation policies. All right, so one of the things that's not well understood in climate these days is that there's really good news from the standpoint of climate policy. So in terms of expectations, if you had a time machine and went back to 2010 and said, well, here's how it looks in 2021, anyone concerned about climate change would have good reason for optimism. There is plenty of data that suggests that the most extreme scenarios that we believed collectively in the scientific community 5, 10, 20 years ago are simply off the table. But that's not the story that you get from the media, from many scientists, certainly from politicians. And what I'd like to do today is spend a little bit of time just diving into the massive, many thousand pages of the IPCC report in areas where I have expertise and just give a clear-eyed presentation of what the report conveys. And it's a mixed message. I'll just say that up front. The IPCC does some things very well, and it does some things not so well. So here's the summary. Here's the bottom line for what the IPCC says on extremes. And I use the language of detection and attribution exactly as done by the IPCC. And if you take a look at these different categories of extremes, the IPCC makes judgments on whether trends have been detected, and if there are trends, whether they have been attributed to human causes, whether greenhouse gases or otherwise. And let me say that the top line story is, again, very different than what we would get if you listen to the media or many scientists. The strongest evidence for detection of trends, and when I say detection of trends, this is over the longest period of record for which there's data, as I think everyone knows on this. In this audience, if you start and stop your data set at different points in time due to climate variability, you can always find up or down trends. But this refers to the ability to detect trends beyond that of natural variability. And the strongest evidence is for heat waves and what is called heavy precipitation, both of which to some degree have been attributed to human causes, with heat waves having the most strongest attribution. Not for flooding, not for meteorological or hydrological drought, not for tropical cyclones, winter storms, thunderstorms, tornadoes, hail, lightning, extreme winds, which are straight line winds, and fire weather has been detected and attributed. And what I'd like to do is I'm going to go through a few of them to give you a sense of what the IPCC reports, and then have a summary at the end. I put this here. You don't have to read this. Lost in the discussion, particularly the popular discussion and the policy discussion, often are the definitions of climate and of climate change. It's important to understand that climate is a statistical property of weather and other events measured over many decades. And climate change refers to a change in those statistics. Climate change is not a causal agent. Climate change does not fuel weather. Climate change does not cause weather. It would be incorrect to say that this or that storm was made worse by climate change. And I get it. Often climate change is used as shorthand for greenhouse gases, but it has made the discussion difficult because that sloppy language has slipped its way into IPCC reports in the scientific literature as well. So I'm a little bit of a stickler, and I insist that, particularly when we're talking about science, terms mean what they mean. So when I go through this discussion, I do mean climate and climate change as defined by the IPCC glossary, as you can see here. Detection, again, the IPCC defines detection as observing, in a statistical sense, a change in the statistics of a particular phenomena. And any particular phenomena can be measured in multitude of ways. So tropical cyclones, you could have frequency, you could have intensity, you could have their propagation rate, you could have their rainfall amounts. So it's very important when we talk about extreme events to be exceedingly precise in what it is we are talking about. Too often the phrase extreme events is used as a bucket, a big bin, and it by itself doesn't mean much. And attribution is identifying the causes for observed detected changes. So I'm going to go through these one by one. But this is the strongest conclusion of the IPCC for extreme events. Virtually certain there's been increases in the intensity and duration of heat waves and in the number of heat wave days at the global scale. Heavy precipitation. The frequency and intensity of heavy precipitation have likely increased at the global scale over a majority of land regions with good observational coverage. Now, heavy precipitation is a tricky one for communication, and sometimes it's a benefit and sometimes it's a problem depending on who you are. But heavy precipitation is not the same thing as flooding. If we were to get 2 centimeters of rain in Boulder today, that would be a heavy precipitation day, given the time of year, but it wouldn't lead to flooding. For the first time in this report, the IPCC is explicit. It says heavier rainfall does not always lead to greater flooding and has a good explanation why. This has generally been known, but heavy precipitation is often measured statistically and doesn't necessarily correspond to societal impacts. We did a paper about 20 years ago, 18 years ago, where we looked at the relationship of scientific definitions of heavy precipitation and flooding and societal impacts, and they weren't well correlated. And so it's really important, if you're talking about flooding, to talk about flooding. Here we go, flooding. Confidence about peak flow trends over past decades on the global scale is low. Some regions experiencing increases and some experiencing decreases. So the confidence about flood trends is low overall. It would be inappropriate to say that we have observed a worldwide increase in flooding. Drought. Now, drought, the IPCC changed how it referred to drought. I include the definition of drought the IPCC uses, and there's some text here from the Working Group 1. But for hydrological and meteorological drought, which is what most people think of when they think of drought, there's limited evidence and low confidence for trends globally or at the regional scale, and they say with few exceptions. The IPCC does assert that soil moisture drought, which they now call ecological and agricultural drought, they have medium confidence that there have been trends detected and attribution given. Medium confidence refers in the IPCC vernacular to a 5 in 10 chance, so 50-50. Tropical cyclones. I could give a whole series of talks on tropical cyclones, studied that topic for almost 30 years. There's low confidence in most reported long-term, multi-decadal to centennial trends in tropical cyclone frequency or intensity-based metrics. For better or worse, ever since Al Gore's movie poster in 2006 had a hurricane spinning the wrong way coming out of a smokestack, tropical cyclones have really been at the center of discussion, debate, promotion, advocacy for climate change, and that's really unfortunate because there's really a lot of interesting science and a lot of wonderful scientists doing work on this topic, but there's not anything close to certainty. The latest, I guess, misleading set of assertions that are made are to start data sets around 1980 and to say there's been upward trends since that time, and that's undoubtedly true for many indicators worldwide and in the Atlantic. A new paper by Vecchi et al. Assert that in the Atlantic, the 1970s up to about 1980 was the quietest period in several centuries for the Atlantic. So again, it's no surprise that you'd see upward trends from 1980, but that's why the IPCC accurately talks about long-term being multi-decadal to centennial, which is a very responsible statement. Doesn't always get translated. Winter storms, I'll just zip through these. Low confidence for winter storms. Thunderstorms, tornado, hail, and lightning. It is not straightforward to make a synthesizing view of observed trends. Again, I've done research on these topics, and I think that's particularly a fair conclusion. In the United States, which has a high proportion of global tornado observations, there is evidence that at least in the last few decades, tornado occurrence has decreased overall. Extreme winds, again, not in the polar areas, but for most of the planet, it's becoming less severe. So a lessening of extreme winds. Fire weather. So fire weather is weather conditions that promote wildfires, more probable in Southern Europe, Northern Eurasia, the US, Australia over the last century. Again, medium confidence, so a 50-50 chance. So let me just point, when you're a subject matter expert and you read the IPCC, not having been involved in its creation, you see things that probably the lay reader wouldn't see in your area of expertise. So I just want to point to one example that some are still playing some games in the IPCC. So here's an assertion in Chapter 11. There's an increasing trend in normalized U.S. hurricane damage. So I was very happy to see this, of course, because with Chris Lancy, we came up with the original methodology and terminology of normalized damages. If you don't know what that is, that's okay. I'm not going to explain it today. And they cited one paper to say there was an increasing trend. Now, right away, I knew there was an issue. Here's a literature review I published earlier this year on all normalized damage studies that have been published since our first one. There's 54 normalization studies in the literature. 53 make no claims of attribution. The one that the IPCC cited was the one study out of 54 that made a claim of attribution. So for me, it means they either weren't aware of the broader literature or they selected one that had a particular message. Now, if you look specifically at the literature on U.S. hurricane damage, the study they highlighted has 25 citations and has an upward trend. It's not a good study. I won't go into that. The study they ignored is one of ours with 1,216 citations. So when the IPCC plays fast and loose with areas of science, it's readily seen by people who have expertise in that topic. So in general, it's good not to do that. So in summary, overall, and we can pick nits, and there are some issues with emphasis, and some authors oversighted themselves and so on. But overall, this summary table I prepared is, I think, a very good representation of my understanding of the literature on extreme events that I've been following for 30 years. And really, the two places where you can make strong claims of detection and attribution are heat waves and heavy precipitation. There's some real questions about any of these other phenomena. If you look at the media, or you look at policy, advocacy, or even what some scientists say, it does not square particularly well with what the IPCC says.